One thing that you might notice here is that if these points are selected, depending on the random number, they may fall off of the screen. And that's because the limits that we're setting for our plotting window are based on our first call to plot. And this is just being added to that. So if the points that we're adding fall off of the plot, that means that we're not going to be able to see them. So what you might want to do is change the limit on your axes to make sure that all the plots are going to be visible. Now, especially with plotting functions in R, it's really common to stack up a whole bunch of arguments. And the way I like to format lines of code when I have a lot of arguments is to break them up so there's one argument per line. Now, there's no problem with putting a single line of code across several lines, especially with graphing functions. I find this much easier to read, especially if they get so long they start going off the screen on the right side. It also makes it really easy to copy and paste groups of arguments from one function to another, which is something you do more often than you might expect when you're coding in R. So, these arguments can go in any order as long as I specify them. So I say, well, I want to, oops, sorry, I'm in the wrong place. For my plot, I want to set my xlim and ylim. And in order to do that, I need to do that after I know what my values of y are. So I'm going to have to move this line of code up here. So I know what my y is before I try to plot it. And now I can set my xlim argument specifically to control the scaling on the x-axis. Oops, and I'm sorry, it's not the x-axis I need to mess with here, it's the y-axis. You can control the x-axis the same way, but that's not our target here. And this argument takes a vector of two values, so I can create that vector with the C function. And those two values are simply the minimum and the maximum value that you want this to be. So in order to make sure that I capture all the points of both the fx and the y variables, I can use the min function to say I want the min of fx and y for my smallest value, and I want the max of fx and y for my largest value. So let's break this down. I'm passing one argument called ylim. I'm using C to create the vector. And to create that vector, I'm calling another function that's going to give me the minimum value of fx and y combined. And the second value of this vector is going to be the maximum value of fx and y combined. And that will make sure that my axes are scaled large enough so that you'll be able to see all the points in fx and y, no matter what those random points are that are generated. So after doing this and running this source, you'll find, especially here in the lower values, that you will never miss out on values that are too low. And up at the high end, you'll never miss out on values that are too high. And you'll see that the axes are rescaled a little bit every time if you have high values and low values near the ends. So that's just a trick for making robust plotting to make sure that you're never missing out on seeing the data that's being plotted, as you have some direct control over those limits. And you can write code to calculate those.